There is one final thing that we need to look at in this section. And actually you're going to find this considerably easier than the last couple of videos. We need to talk about what we're going to call Riemann sums. So you're going to need the worksheet titled Section 4.2, Day 3, In-Class Riemann Sum Examples. If you don't have that right now, take a moment and go get that out. A Riemann sum is really just a fancy term for any of our area approximations. Left endpoint sum, right endpoint sum, midpoint sum, trapezoid sum. Any of our area approximations. And this is going to sort of go back to that first video in this section that we looked at where we found a right endpoint sum, a left, a midpoint, a trapezoid. But I want to just do this from a couple different perspectives. We'll do this from a table of values. We'll do this from a graph. And this is something that will definitely show up on the AP exam. You'll be asked to approximate an integral using a table of values on one or multiple free response questions. Take a moment and read problem number 1. I want to approximate this integral, and I want to use a left endpoint sum. Well, one thing that sometimes helps me with these problems is drawing out a little picture of what's going on, so I'm going to do that. I've got 0, 0.5, 1, 1.5, and 2 for my tick marks. Let's see, I want 3, 5, 8, 13. So I'm going to have a height. I'm going to have a point at 0, 3, a point at 0.5, comma 3, a point at 1, comma 5, a point at 1, comma 8, and a point at 2, comma 13. I think I said that wrong, 1.5, comma 8. And I'll actually draw in little heights at all these places. It's the height of my function at 5 different places. I want to approximate this using a left endpoint sum. So I'm going to draw in some rectangles whose height is the height at the left endpoint of the region. So between 0 and 0.5, I'll draw in a rectangle that looks like this, with the height at x equals 0. Between 0.5 and 1, I'm going to draw in a rectangle that looks like that. 1 and 1.5, a rectangle like this. 1.5 and 2, a rectangle like that, because again, I'm using my left endpoint sum. My area approximation is going to be my base of 0.5 times the height at the left endpoint. 0.5 times f of 0. Second region, my base is 0.5. The height I'm going to take at the left endpoint, so f of 0.5. Next one, 0.5 times f at the left endpoint, that's f of 1. And the last one is 0.5 times f at the left endpoint, f of 1.5. How are you going to get these values? Well, you're just going to pull them from the table. This is going to be 0.5 times 3 plus 0.5 times 3 plus 0.5 times 5 plus 0.5 times 8. Go to the calculator, finish this off, and give me the approximation of this integral from this very little information that you were given. I think when you go to the calculator, this should give you 9.5. That is not the actual area under our curve. It's just an approximation, but it's the best we can do given the really only 5 points that we were given here. Number 2. We have another function, f of x. Here are some tables. I want to approximate this integral using a trapezoid sum. One thing you should notice is the bases, they're all a little different. And that's actually totally fine. We can still do, this still counts as a Riemann sum even if the bases aren't all equal. I'm going to draw this out. I've got 1, 4, 6, 7 as x values. Let's see, 10, 20, 30, 40. My height at 1 is 10. My height at 4 is 30. My height at 6 is 40. My height at 7 is 20. And I want to do trapezoids. So my trapezoid between 1 and 4 is going to look like that. Trapezoid between 4 and 6 will look like this one. Trapezoid between 6 and 7 will look like that. Area of a trapezoid, remember, is the base times the average of the heights. So this first trapezoid is going to have a base of 3 and a height of, well, the average of the heights, a height of 10 plus 20 divided by 2. On this formula, we'll find the area of the first trapezoid. See if you can write out the area formulas for the next two trapezoids, realizing that your bases are changing. Base is 2, and then I want the average of the heights, so I need to go back to that first one. It's not 20. I'm sorry. It's 30. Second one is 2 times 30 plus 40 over 2. And then the third trapezoid, base is just 1 as you go from 6 to 7. And I want the average of the heights, so 40 plus 20 over 2. Go to the calculator. Actually, you know what? No. Let's see if we can do this one without a calculator. This would have been on a non-calculator part of an AP exam. I think the numbers are nice enough. See if you can finish this off and tell me what letter you have for the answer. 40 divided by 2 is 20, so 3 times 20. You know what? I can just make those 2's over there cancel. 30 plus 40 is 70. 40 plus 20 is 60, divided by 2 is 30. So this should be 60 plus 70, 130. Plus 30 should give you 160, or letter C. Turn the page. Using a midpoint Riemann sum this time, approximate that integral. Okay, well, I don't know what the graph looks like, but all I really care about is the number line. I'm going from 0 to 1, 1 to 2, 2 to 3, and we're just going to cut off the rest of that. Oh, you know what? That's going to bother me. Hold on. Very good. The magic of whiteout. Okay, so I am told to use a midpoint Riemann sum. My first rectangle is going to go from 0 to 1, so my base is 1. My height is the height at what x value? Well, because we're doing a midpoint Riemann sum, I want to get the height at the midpoint of 0 and 1. So whatever f of 0.5 ends up being. You'll do that for the next region. Between 1 and 2, you're going to find the height at the midpoint at 1.5. Get your height, draw your rectangle. It's going to be 1 times f of 1.5. That last region, again, the base is 1. The height is the height at the midpoint, so f of 2.5. You're going to find these three values by plugging into your function f of x equals the square root of 1 plus x squared. Go to the calculator to do this. Find f of 0.5, f of 1.5, f of 2.5, add them up, and then tell me which of those answers is closest. I am thinking 1.118 plus 1.8028 plus 2.6926, and when you add them up, you're getting letter A. One final one. Trapezoid rule with n equals 4, that just means 4 regions to approximate that integral. Okay, so one region's from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Wait, hold on. No, I don't want that, sorry. I'm going from 1 to 2, 2 to 3, 3 to 4, 4 to 5. Those are my 4 regions. I don't have a formula, I don't have a table, but I do have a graph. And I can still draw in my trapezoids. Here's one trapezoid. Here's my next trapezoid. My next trapezoid. My last trapezoid. There we go. You know what? I think you can probably figure this out. See what you can do here. Let's try to not use a calculator on this one and send the answer into Edpuzzle. First trapezoid, base is 1, height is the average of 1 and 3. Next trapezoid, base is 1, then the average of 3 and 1. Next trapezoid, base is 1, height is the average of 1 and 2. Last trapezoid, base is 1, height is the average of 2 and 3. And look at that. Okay, well, 4 halves plus 4 halves plus 3 halves plus 5 halves. Might as well just keep them all together like this. I am thinking 16 halves or 8. I can absolutely, positively guarantee you, you will have to do some of these approximations on a free response question on the AP exam. Most likely, looking more like 1 and 2, where you're given a table of values and we're asked to find an integral using a left endpoint sum, right endpoint sum, midpoint sum, or trapezoid sum, and get the information from the table. We will see a few more of these as we move on through the rest of the course.